Let's see this. Now I told you that this is known as functional, and we have to find the extremal value of this functional. The working procedure was find out del f by del y dash, put it in the Euler's equation, equate it to 0 and solve. Okay, this is called the Euler's equation. Now in this, there are few questions where you can reduce your effort. How you can reduce your effort? In case the given this extremal, this functional, suppose this functional is independent of x. If you don't have x there, in that case, Euler's equation is reduced to this format. So you can directly use this. You can use this one as well, but when you will solve it, it will become little bit complicated. So you can directly use this reduction. So what you have to do, put the value of f, y dash and del f by del y dash and equate it to a constant rather than 0. Right? So this is the second category now we are going to discuss. Let us see one question based on this. All of you please note down this and come to the question. Right on the first question, my question is, prove that the shortest distance between 2 points in a plane is a straight line. X1 and X2 are 2 points. I have joined them with a length S, and I am saying the shortest distance is a straight line. Straight line means y is equal to mx plus c format. Okay, that we will see at the end whether we are getting it or not. Let us now first start. I am talking about this length. So first step, you should define your function, right? Clearly when you talk about the length of an arc, it is x1, x2, ds. Okay, now remember one thing, whenever you have ds and you are talking about a length, this ds can be substituted by under root 1 plus y1 square dx. In differential calculus, we have this ds is equal to under root 1 plus y1 square dx. So now this is my functional. Now clearly this f is independent of x. I don't have x. So I can use the second form of Euler's equation. What is my Euler's equation now? It is f minus y dash del f upon del y dash is equal to some constant. So let us put the values. F means under root 1 plus y1 square minus y dash. Del f by del y dash is what? 1 upon 2 under root 1 plus y1 square and then 2y1. y1 and y dash is the same thing, okay? This also I should write actually y1 is equal to constant. Right? Let us try to solve this. 2 and 2 got cancelled. Bring it here. 1 plus y1 square root. When you multiply, you will get this. Minus y1 square is equal to c under root 1 plus y1 square. This went on the other side after the LCM. Now if you open the bracket, see y1 getting cancelled. So what you got? 1 is equal to c under root 1 plus y1 square. Now simple algebra I am doing, I have got the differential equation. So 1 upon c square is equal to 1 plus y1 square, right? And then next step is y1, one second students, y1 square is equal to 1 by c square minus 1, which is equal to 1 minus c square upon c square. Right? And this is the value of this I have solved. It is some constant only. So let me replace it by k just to avoid the complications. Okay. So now next step you have here y1. Rather, if you can take y1 is equal to under root of this and then replace it by k. So y1 is equal to k. Okay. So dy by dx is equal to k. Right? Now dy by dx is equal to k implies what? Dy is equal to k dx. Integrate y is equal to kx plus some other constant c1. So what is this? It is an equation of straight line. Y is equal to mx plus c. So we are done. Understood what I did? I saw first I defined my functional. I saw functional was independent of x. So I used the other format of Euler's equation. I substituted. I solved. Here I have replaced this constant by a new constant k. If you don't want to replace, don't replace. Not an issue. Okay. Some constant is coming. That's it. Okay. So this is how you have to do the question where functional is independent of